All right, the last piece here with factoring is how do we use factoring to help us solve quadratic equations? So there's a lot of ways to solve quadratic equations. I actually find that factoring is the easiest. So when you're given a quadratic equation, the goal is to figure out the zeros or the roots. We use those words interchangeably by factoring and solving it, setting it equal to 0 and solving it. So we have some steps down below that we'll go through. First thing you want to do is want to make sure it's in standard form. Standard form means everything has to be on one side with 0 on the other. So you want to make sure it's in ax squared plus bx plus c equals 0. So you may have to do some shuffling of your terms. Second step is to see if there's anything I can take out. So if it has a GCF, if I can take out a 5 or if I can take out an x, you want to take out anything they have in common before you really get going with your factoring. Next step is to look how many terms we have. If it has 3 terms, it's either going to be a basic FOIL factor or it's going to be one where you're going to need to do the AC method. Now I have on here the box method because that's what I've done in the past, but I just showed you another method where you can go through and do it without drawing a box. You can also use the big X method, and that's going to be true anytime you have a number in front of your x squared, like a 2x squared or a 3x squared. If it only has 2 terms, then you're going to check to use difference of squares. And then finally, when you're done and you have your factors, you're going to set each factor equal to 0 to get your solutions. So we'll start with really easy ones that are already factored, and then we'll go into ones that you have to do the factoring for it. So if it's already in factored form, that's what this is called, factored form, you can set each factor equal to 0 individually and solve for x. So you can set x plus 9 equal to 0, and you can set x plus 4 equal to 0. And the nice thing here is you can do this on your head. You usually do not have to do any work for this. You're going to get -9 because that's what's going to make this factor equal to 0. And you're going to get -4 because that's what makes this factor equal to 0. And I have no problem with you showing absolutely no work for that because I realize that you can do it in your head. The next one, for this one, what makes that equal to 0 would be x equals +6. For this one, I'm going to show you the long way and the short way. The long way is to write it down and set it equal to 0. You're going to subtract. And then you're going to divide. And you get -2/3. There's also a shortcut that I use a lot, and so I'm just going to mention that shortcut because I'm going to try to use it as much as possible. The shortcut to find a solution when you have a number in front of your x, your solution will always be the opposite of the constant, so the opposite of 2 is -2, divided by your coefficient in front of x. So you're always going to have the opposite of the constant number divided by the coefficient. And those are your 2 solutions. So if you have to factor, again, first thing you want to make sure is it's in standard form. This one is, and make sure there's nothing you can take out. And then you want to look at your factoring technique. So this is 3 terms with the first term being x squared. So this one's going to be very quick. We need 2 numbers that multiply to get 6 and add to get -5. So that's going to be -3 and -2. So my factors are x minus 3 and x minus 2. We would say that is factored form. And then my solutions come from what makes each factor of x equal to 0. So we're going to set the first one equal to 0, we get 3, and then the second one equal to 0, we get 2. Next one is not in standard form, so we're going to add 8 to both sides. So we get x squared plus 6x plus 8. No GCF, very quick FOIL factor. I need 2 numbers that multiply to get 8 and add to get 6, so we get 4 and 2. So one of my factors is x plus 4, and one of my factors is x plus 2. Does not matter the order that you write your factors. So then my solutions are what makes each factor equal to 0. So the first one will equal 0 when x is -4, and the second one when x is -2. Here's what you're finding visually. What you're finding is on your parabola, these are the values where it crosses the x-axis. That's what you're finding. You're finding intercepts. So if you were to graph this on your calculator or graph this by hand, you would see that at -4 and at -2, this parabola would cross the x-axis because those are the places where the function equals 0. You're finding those x-intercepts. So you can always have a visual verification if it helps you to see what your answers actually mean. Here are a couple difference of squares. So first thing I notice is they're in standard form. I don't have to move anything around. It is 2 terms with a minus sign, and everything is a perfect square. So this is going to factor 2x plus 3, 2x minus 3. Now, when I solve difference of squares, you're always going to get 2 answers that are opposites, meaning one's going to be positive and one's going to be negative. So to find this, it's going to be the opposite of 3 over 2, so -3 over 2. And then this one is going to be the opposite of negative 3, which is positive 3 over 2. It is perfectly acceptable for you to write your answers all at one time and say that your answers are plus and minus 3/2. That indicates both the positive and the negative. I'll do that for this next one so you can see it. So this factor is 4x plus 5, 4x minus 5. So my solutions are plus and minus 5 over 4. These I need to get in standard form, so I'm going to subtract 8x. So I have 2x squared minus 8x equals 0. This one actually has a GCF. We can take out a 2. We can also take out an x. So when I take out a 2 and I take out an x, I'm left with x minus 4. In this case, I am ready to solve. That is fully factored. There's nothing else I can do. So I need to see what makes this equal to 0, and that's going to be true at 0. And then what makes this factor equal to 0 will be 4. So I will get two solutions, 0 because of the x that's in front of the parentheses, and 4 because of the x minus 4 in parentheses. The next one is not in standard form, so I'm going to add 4 to each side. So I have 2x squared plus 6x plus 4. The other thing I notice is everything is divisible by 2, so I'm going to pull a 2 out as my GCF. So I have 2 times x squared plus 3x plus 2. Now I'm going to see if I can factor further. I need two numbers that multiply to get 2 and add to get 3. That's going to be a plus 2 and a plus 1. My solutions, so a lot of times students will ask, what do I do with this? If there's no x value, there's no solution that comes from it because there's nothing that will make that equal to 0 because it's a number, not a variable. I do get a solution from each factor of x. So from my first factor, I get negative 2, and my second factor, I get negative 1. This one is in standard form. There is no GCF. I'm going to do that AC method. So I'm going to multiply your A and your C. So 4 times 25 is 100. I need two numbers that multiply to get 100 and add to get negative 20. So that's going to be a negative 10 and another negative 10. So I'm going to write it as 4x minus 10 and another 4x minus 10. I can take out a 2 from everywhere. So when I divide everything by 2, I get 2x minus 5 and another 2x minus 5. If you want, since it's the exact same factor, you can actually write it as 2x minus 5 and then square it. With this, when you have the same factor twice, we call that a repeated factor. We only get one answer. My only answer is the opposite of negative 5 over 2, so it's 5 over 2. And that is a single answer. This one's similar. I'm going to skip over that. I'm going to jump to this one. So I need to get this in standard form, so I'm going to subtract 4. I have to do the AC method because I have a leading coefficient, so 5 times negative 4 is negative 20. I need two numbers that multiply to get negative 20 and add to get 1. So that's going to be a positive 5 and a negative 4. So I have 5x plus 5 and 5x minus 4. I can't take anything out of the second factor, the 5x minus 4, but I can take a 5 out of the first factor. So I get x plus 1 and 5x minus 4. So my two solutions are negative 1 from the first factor and positive 4 over 5 from the second factor. Let's do one more. Let's get this in standard form. I do like my x squared to be first and to be positive, so I'm going to leave that where it is, and I'm going to subtract the 16x, and I'm also going to subtract the 12 to get everything on one side. AC is negative 36 when I multiply 3 and negative 12. So my two numbers that multiply to get negative 36 and add to get negative 16 are negative 18 and 2. So we have 3x minus 18 and 3x plus 2. I can take a 3 out of both terms in this factor, so I get x minus 6, 3x plus 2. That is the factored version or the factored form. My solutions, my first factor gives me a solution of 6 because that makes that equal to 0. And the second factor, my solution would be negative 2 over 3. So that is how I use factoring, all the different techniques I've learned, in order to solve a quadratic equation.